Hey, today we're going to do 7-4. It's about scientific notation, which you guys have probably already seen in science class. So I'm not going to spend a lot of time explaining how to put numbers back and forth, but there is going to be a cool thing that we're going to do with it. So basically, a number is in scientific notation if there is only one non-zero number on the left side of the decimal, and then you put the times 10 to the whatever exponent. Let's just do an example. Here I see on 1a, if I wanted to have this in scientific notation, again, you can only have one non-zero between the, one non-zero on the left of the decimal point. So I'm trying to put the decimal point right here. So let's count how many places I had to move that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops. You know, the pen didn't hold, but there it is. I need to move it 10 places. If you want something to be bigger, you're going to multiply it by the bigger number, right? That's what's going to be a positive. So this is going to be 6.87. You do not need to write any unnecessary zeros. These don't really tell me anything. I'm replacing all those by saying times 10 to the 10th. If it is a little number, you'll use a negative exponent. So here I want to move the decimal point to there. So that's 1, 2, 3, 4, 5 places. Since I'm making it a small number, that's going to be a negative exponent. 10 to the negative 5th, and it'll be 7.25. So if I want to go the other way, I just kind of write down the original number and put my pen where the decimal point currently is, and since it's a positive 6, that means the number should be bigger, so I go to the right. 1, 2, 3, 4, 5, 6. Fill in any empty holes with zeros, and that's your answer. Add some commas. Boom. Same thing here. 903, since it's a negative 5, I go left. 1, 2, 3, 4, 5. 0.0000903. So let's actually try adding and or subtracting these together. I'm going to pretend that these 10s are actually like little x's. And that's going to allow me to do normal numbers doing normal number things and adding exponents. So like 6.5 times 8.7. I'm going to have to grab my calculator real quick. 6.5 times 8.7 gives me 56.55. And then, remember in 7.1 when I was like, oh yeah, x squared times x to the 5th is x to the 7th. You just add the exponents. And the reason you were allowed to do that is because the bases are the same. Same thing here. The bases are the same, so you can just add the exponents. So I end up with times 10 to the 12 minus 15 is negative 3. Now, this is not in scientific notation. Read the directions. Express the results in both scientific notation and standard form. This isn't in anything, actually. If I want it to be in scientific notation, I need to move this decimal point one place to the left, which means I want 5.655 times 10 to the first power, right? But don't forget, you still have this 10 to the negative 3 here, so drop that down. And then, once again, you have bases the same where you can add the exponents. 5.655 times 10 to the negative 2nd. Okay, now I can write that in standard form. 0.05655. Both of these would be my answer. The other thing you could have done when you were up here is you could have, when you were here, is you could have just quick rewritten that. Move that decimal point 3 places. 1, 2, 3, 0.05655. That looks familiar. And then after that, you could have put it back into scientific notation, which would have been 5.655 times 10 to the negative second. Oh, hey, that looks familiar. Okay, either method would have worked. Same thing's going to happen when you do division. Normal numbers do normal number things. So I'm just going to divide those. I got to grab my calculator here. 2.3958 divided by 1.98. Normal numbers do normal number things. Times, and with exponents you can subtract 10 to the negative fifth. Since there's only one non-zero left of the decimal point, it's already in standard form. So now I just need to write it in standard form. 1, 2, 3, 4, 5. I'm out of room. Okay, so 0.1234 zeros. And that's my answer.